What's up guys, welcome back to a brand new YouTube video, and today I've created a gravity simulation. Now we are using CMU graphics for this. I swear I'll learn a better visual graphics library or a better framework at some point, but for now we're stuck with CMU graphics. Alright, so first let's run this, see what happens. So you can see I can click with my mouse, and we have a little blue particle over here. If I click again, they start moving towards each other. And you notice they change color. See what happens if I add more. You can see they start kind of clumping together. Something I'm really proud of is that the particles will try to make a circle shape, kind of similar to real life, how large objects are always circle spheres, just like our Earth. These guys try to make circles. So let's keep adding particles. And the second change you'll see is that the color starts changing. They're all the way out here, they're blue. Slowly, as the gravitational force gets stronger, they start to turn green. And if you added in a bunch of particles, you'd see them slowly turn yellow and then red. And red is actually the maximum gravitational force in this simulation. We have a particle counter up here. So now that we have 30 particles, let's see if I can try to get an orbit in. So you can add velocity by kind of fleeing the particles just like that. Let's see if I can do it. Okay, you can see he's kind of curving around. I think we got it. Yeah, looks like it. Alright guys, let's go. Usually it's pretty hard, so I'm glad I got it pretty fast. But you can see here a pretty stable orbit. My guy's going around like this. Pretty soon what I want to add is I want to see if I can figure out if something is in orbit and then add like an orbit line. But I think that's going to be pretty difficult, so we'll see how I can implement that later. Alright. So we've got this kind of clumping behavior, how it'll make something circular. Something else you'll notice is as you add more particles, it starts looking really weird. And you can see it kind of sets a size limit. If I were to add more particles to this thing, it wouldn't get any bigger. You see it stays roughly the same size. Let's see what happens if I turn the gravity down a little. Instead of the gravitational constant being 20, let's make it 1. See, first of all, right off, normally the particles are turning green and yellow inside this clump, but now they're all just staying blue because the gravitational force is really, really weak. And the second thing you can notice is that my clump is not as circular. This is also similar to real life. When you see something that doesn't have a lot of gravitational force, it's going to tend to not. It's trying to be circular, but it just doesn't have a force to overcome these the collisions. So you can see it's not completely circular, and we also have a bigger size. Let's see what happens if we crank this thing up all the way to 100. You can see, even when my particles are all the way over here, they're still moving towards each other, really slowly, and then faster and faster, because gravity is, of course, an inverse square relationship, the force of gravity. And you can see turning yellow, that's a lot of force right there. And when I add 3, they start vibrating kind of crazily. You can see here, as I add more and more, it turns more red, and the size is really, really small because the gravity is working really hard to bring all of these different particles together, which I think is super cool. And now if I try to add an orbit, it'll probably be a little easier. I might have to give my particle a little more velocity, and let's see if we can get it. Oh, not quite, a bit too fast. See, I told you it can be tricky. But here we go, I think we got it. There's a stable orbit with 2 particles. Oh, looks like it might get sucked in here. Oh, did you see that? Super cool stuff. Alright. Now, something else is, when you turn the gravity up, it makes the orbits a lot easier. But when I turn the gravity down, the orbits become a lot harder, because it's harder for the particles to lock in place. You can see here, I can try to get them to clump up, make a circle. I can try getting an orbit in, but it's just so hard because the particles have almost 0 attraction. But let's see, here's something cool I figured out. You can actually get some pretty cool looking collisions with low gravity. Let's just fling a particle as fast as we can. Boom. That was pretty satisfying. Let's do it again. Let's see if we can hit it. Oh, there you go. Kind of took a bit of it off there. Yeah, you don't get that kind of behavior when you have a really massive gravitational constant because everything just stays together. Let's see if we can get something even cooler looking. Maybe with particles like flying off. Gotta hit it on the edge to grab the particles on the edge, because the gravitational force is a little weaker there. So now that we have a bunch of particles, we're aiming for one of the edges right here, and let's go. Ah. And you see we just took like a chunk of it off there. That was super cool. Bam, took another chunk off. Once again, bam, just ripped the entire thing apart. That's super cool. And that's pretty much it. I've had a lot of fun playing around with this. It is in my GitHub if you want to play around with it. You'll have to import the CMU graphics library. But yeah, super cool stuff. The gravitational number, constant number that I found works best is 20. Pretty good for all your practical purposes. Oops. Good for all your practical purposes. You get the clumping behavior. You can see the color changing as the gravitational force gets stronger. We can get an orbit in. Get an orbit in. Get an orbit in. Something like that. We can also get those collisions. Bam. Super cool. Just before I end the video, I'd like to quickly go over how it works. So we can see here we're using the CMU graphics library, importing math, importing PyAutoGUI. This is just to get the screen graphics stats so that we can like set the simulation size to be the size of your screen. Doing that right here, setting up all our constants, gravitational constant, mass, etc. We're defining our distance squared function here, so we can use it later when we're trying to find the distance between two particles. We're using an angle2 function here to find the angle between two particles, and then in order to implement the particles, we're making just a class called the particle, and inside our class we have a constructor, and we have a bunch of different other functions. We've got a calculate force function to figure out the force between this particle and all of the other particles, which we're storing inside a list called particles. We got a move function that's basically just going to use the force that we calculated, and it's going to move the particles based off of that force. Then we've got a resolve collisions, which is basically just going to take two particles. If they're overlapping, it'll move them both out by half the overlap. Then we've got an on mouse drag, on mouse press, on mouse release. This is all for the particle spawning. And then we've got an on step. This controls what happens every frame. All right, guys, thanks. See you in the next one.